Okay, we're going to be reviewing Chapter 8, Sequences and Series. So the first thing you're going to be asked to do is to write the first four terms of a sequence. So what we're going to do for number 1 is we're going to look here at this rule they give us, and we're going to start with 1, and we're going to plug 1 in anytime we see an n. So you can see here I plugged a 1 right in front of our parentheses and a 1 here where we'd put the other n. Then you're going to use your calculator and you should get 8. Do the same thing, put a 2 here and a 2 here. You should get 22 when you put it in your calculator, and so on. We'll plug 3 in, and then 4. So just make sure that you're using your calculator correctly and that you're plugging it right into this rule right here. The second thing you're going to have to do is to look at a pattern and figure out what the rule is, and then figure out what the next term will be in that pattern. So when we look at number 2 here, we see that we're going 3, 9, 27, 81. So what I noticed about this is that they are increasing quickly. Okay, so I'm just going to write increasing quickly. The next term, let's wait on this next term. Let's see if we can figure out the rule. So whenever I see something that is increasing quickly, I look for exponents. Okay, and remember what we need to do is plug a 1 in right above this 3 right here. And we got to be able to get out a 3. We got to plug a 2 in here, get out a 9, plug a 3 in, get a 27, and 4 to get 81. So what this one comes out to be is our rule is actually going to be 3 to the nth power, because 3 to the first power is 3, 3 to the second power is 9, 3 to the third is 27, 3 to the fourth is 81. So to find our next term, we're just going to do 3 to the fifth power, and we get 243. All right, our next problem is write the summative notation for the series. So just like we did last time, we really need to find a rule, okay? We're always going to start with like n equals 1 or k equals 1, variable equals 1 on the bottom. Then we're going to look and say, well, if we plug a 1 in here, a 2 in here, a 3 in here, what can make that turn into a 6? So what can we do to 1 to change to 6? In this case, our rule is going to be 6n, because 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18. Then we got to figure out 6 times what gives us 96. So we can just do 96 divided by 6 on our calculator. We'll find that that's going to come out to be 16. We need to put that 16 on the top of our symbol. And that's all we have to do for that problem. The next one says find the sum of the series. So we're going to look at the bottom here. This K2 is where we're going to start. And our 4 is where we are going to stop. So we're going to start with 2 and plug it into our little formula here and go up until 4. So we're going to do 3 minus 2 to the third plus, then we're going to have to do 3 minus 3 to the third plus 3 minus 4 to the third. We're going to stop there because that's our stopping point for this problem, because it's on top of the sigma symbol. So then we just plug each of these individually in our calculator. We'll get negative 5 plus negative 24 plus negative 61. We combine all those on our calculator and we'll get a negative 90. Okay, on the back side of our sheet, we're going to start off with telling whether a sequence is arithmetic or not, keyword being arithmetic and not geometric. So for these ones, we are going to see if the number is increasing or decreasing by the same amount each time. So if we look at this, it looks like we are going up 0.5 every single time. So we're going to say yes for this one. Looking at the next one, it looks like we go up by 2, then we go up by 4, then 8, and 16. These numbers would have to be the same for it to be yes. So this is going to be no. All right, so the next one is rule for arithmetic sequence. So we're going to use this formula, and you'll have your formula on your test. You're going to write the rule for the nth term of the arithmetic sequence and then find A13. So the first thing we need to do is we need to find the rule. And to do this, we have to figure out what the difference is. So looking at this, I see that I'm going down by 3 each time. So our difference for this problem is make sure it's a negative 3. If you're going down, you want to make sure you include the negative. Our A1 would be our first term in the sequence. So this is going to be our A1. Now we have enough information to plug into our formula to find the rule. So we're going to have AN equals A1, which is 8, plus n minus 1, and our difference at the end is negative 3. We're going to go through and solve this. an equals 8 plus, we're going to distribute that negative 3 to both terms inside the parentheses. So we'll have negative 3n plus 3. So an equals negative 3n. We're going to combine 8 plus 3 to get a positive 11. There's our rule. That's the first part of your answer. Then we're going to plug this 13 into that rule. So we'll do a13 equals negative 3 times 13 plus 11. Plug that right into your calculator, and you should get a negative 28 for the second part of your answer. We're going to do this again, just with different numbers. My difference this time looks like I'm going up by 5 each time, so my difference is a positive 5. Our a1 is 9. Plugging it into our formula, we'll have a1 equals 9 plus n minus 1 with the 5 at the end as the difference. So an equals 9 plus, when we distribute this out, we get 5n minus 5. So our final rule is 5n plus 4 after we combined our 9 minus 5. Last thing we have to do is plug 13 again into this new rule. So a13 equals 5 times 13 plus 4. Our answer for this one comes out to be 69. Okay, on the next problem, we need to write a rule when they give us the common difference this time and a term. So it's important to label what we have here. So we have a 8 being as our n. Our 50 here this time is going to be an, and then we have the difference as 2. So we're going to use that information to plug into our formula up above. So this time we're going to get 50 equals a1 plus, we're going to plug in 8 for n, 8 minus 1, and then our difference is 2. So we'll get 50 equals a1. 8 minus 1 is 7. 7 times 2 is 14. Now we have to solve for a1. So we need to subtract 14 both sides. And for this one, we get a1 equal to 36. Now that we have a1, we can go back and find our rule. So we're going to rewrite the 36 into our formula. So we'll have an equals, our first term is 36, plus n minus 1 with a 2 at the end as our difference. So just like we did on the problems above, we're going to solve this. An equals 36 plus 2 times n is 2n. 2 times negative 1 is negative 2. So our rule for this one would be an equals 2n plus 34. All right, the last one on this page, finding the sum of finite arithmetic series. So we're going to use our formula right here, and we're going to plug in some numbers using the information given below. So what we need to do first is we need to we're going to start with 1 and plug a 1 right here into our formula. So we're going to do 5 plus 7 times 1. Type that into your calculator. That's going to give us 12. This is going to be your A1, okay? That's going to be your A1 eventually when we plug into the formula. Then we're going to do our last term. Remember, this is going to be where we end, so we want to plug 13 into this. This one was where we started. So 5 plus 7 times 13. That's going to give us 96. That's eventually going to be our AN when we put it into the formula right up here. Okay, so now we use those two numbers and plug it into our formula. So our 13 is also our n, okay? So what we're going to have is Sn equals 13, parenthesis, 12 plus 96 divided by 2. We're just going to type that into our calculator, do it one step at a time. 12 plus 96, hit enter, divide by 2, times by 13. We should get 702 for our final answer for that one, okay?
Okay, so these first type, geometric sequences, you have to decide whether they're geometric or not. Be careful you don't get these mixed up with arithmetic because it's two totally different things. So what you want to do is you have to divide first number by the second number. So we would do 20 over 5, see what you get. Oh, sorry, I meant second number by first number. I don't know if I said it correctly or not. So 20 over 5, you get a 4. And you need to make sure for all the rest of the division you get 4 as well. So then we try 80 over 20. That ends up being 4. You got to keep going just in case eventually, if it's not a 4, you're going to have to say no. But if it stays 4, then we'll say yes on this. So then 320 over 80 is also 4. And then I know the notation with the commas might have been a little confusing, but you do 1,280 over 320. All of them are 4s, so then you can say yes. Same thing on number 12. Double check them though. All right, so 10 divided by 2 is 5. And then 50 divided by 10, also 5. 100 divided by 50, what does that give you? It's a 2, and then you can stop because 2 is not equal to 5, so you know this one is no. All right, so you'll have 2 like that on your test. Geometric sequences, deciding if they're geometric, yes or no. Don't get it confused with the 2 you did that Mr. Robertson went over, the arithmetic ones. Next up is writing the rule for the nth term of the sequence and then finding A5. So 2 things you have to do. You have to write the general rule, and then you have to plug in a 5. And so what we're looking for is you need to fill in your A1 right here, and you have to fill in your R. Now, A1 is given to you in these ones. It's just the first number of the list of numbers. So in number 13, your 3 is your A1. You do have to do a quick calculation to get to your R. That's just doing the division that you did like in the previous 2 problems. So to figure out your ratio, you would divide 15 by 3, and you get that that's a 5. So that number is your R. So to write the rule for the nth term, that's just speaking very generally, you want to keep n in your equation. So you would write down an is equal to, fill in your A1, in this case it's a 3, parenthesis R, which we calculated to be 5, and then you keep the exponent part as n minus 1. So this is the first part of your answer. These problems are always going to have a second part where they're asking you to plug in a number, and it's phrased like this: find A5. That just means where you see an n, plug in a 5. So we would say A5, that just tells us we're plugging in a 5. You don't calculate that at all. Equals 3, parenthesis, 5, and then plugging in a 5, so you have 5 minus 1. And so then what we need to do, let's zoom in a little here. You need to calculate the 5 minus 1, which you know to be 4. So now we have 3, parenthesis, 5 to the 4th. You can type that all in at once. You just have to make sure you put parentheses around your 5. And so what we get...
1,875.
Thank you so much. You are correct. 1,875 is the second part of your answer. So 2 parts, okay? The general formula, keeping n as in part of your answer, and then plugging an actual number in for n to get out a number. All right, let's do that again in this next one. And so, let me zoom out. You know that the first number listed is your A1. And so 32, that's A1 for us. You do have to calculate your R. And so you're going to calculate that by doing the second number, which is 16, over the first number, 32. Yep, so you can write it as a fraction or you can write it as a decimal. It's just 0.5. From there, we'll take both of those pieces and plug that into our formula. AN is equal to 32, which is your A1, parenthesis, R, which is 0.5, and then the exponent you write as n minus 1. Let me add in here so when you go and watch the video, you know that that's R. All right, next up, where we see an n, we're plugging in a 5. So we would say A plugging in a 5 equals 32, parenthesis, 0.5, 5 minus 1. We know 5 minus 1 is 4. I like to write the next step. 32, parenthesis, 0.5 to the fourth. So you guys have to plug that in. And what do we get?
2.
Just an even 2. All right, so 2 is the second part of your answer. Remember, there's 2 parts to those ones. Writing the general formula and then calculating it. Question? Here, let me, can you guys see this okay? All right, so then we take it one step further in the next 2 problems, and these are, they're similar to the ones we just did, but in these ones, they do not tell you what A1 is. So you will have to calculate your A1. They do give you this information where they tell you if you plugged in a 3, you got out an 8. So that 8 is representing AN, the 3 is representing N. And so when you go to plug these into the formula, you should still have A1 as A1. You should not put a number in place of A1. So you'd have 8 is equal to A1, which we're trying to find. R they give to you is a 2. And then normally it's to the power of n minus 1, but we know n in this problem is a 3, so it's 3 minus 1. And then you'll go through and you're going to calculate this part of it. So you have 8 is equal to A1, parenthesis 2. 3 minus 1 is a 2. And then you know that 2 to the second power is 4. So 8 is equal to A1 times 4. And since the A1 is just being multiplied to the 4, we undo multiplication with division. You can divide both sides by 4. These ones are gone. And your A1 is equal to 2. But now you're not done. Now that you know your A1, you know your R, now you put them into the just general formula. So AN is equal to A1, which is a 2, times R, also a 2, and then you leave the exponent part back to being n minus 1. We don't plug anything in for n. That would be your final answer.
Why don't you change the n back to the...
Because on this one, we just want it to be the rule, the general rule we call it, to where you could plug anything in for n. Okay? You would not want to put n back to being a 3 unless you change that an back to being an 8. Because a 3 wouldn't apply to everything. Do you know what I mean? If the first part is left as an, that's saying we don't know what that is yet. It all depends what you plug in for n. So just try to remember to keep that second part of it just general rule, leaving n in it. We'll try it again here on 16. So same set of directions. It always helps, I think, to label the different parts. So 20, this is your, 200 is your AN. You only get 200 when you plug in a 4 for N. And the whole goal is we don't know what A1 is because the general formula needs a number in place of A1. And so you'd write 200 is equal to A1 parenthesis R is 4. And then normally if it was just the general rule, it'd be n minus 1, but we know we got out a 200 from plugging in a 4. So n is 4 minus 1. And now you keep calculating, so this is what I'm going to calculate next. So I rewrite this first part, 200 is equal to A1, parenthesis 4, 4 minus 1 is a 3. From there, what is 4 to the third? Can anyone type?
64.
Thank you, 64. So 200 is equal to A1. It's just being multiplied by 64. You can then divide to get A1 by itself. And a decimal is fine. So what does A1 end up being? I think it's 3 point something.
3.125.
125? Okay. Once you know A1, into the general formula where you have n's still in the formula. Oops. AN is equal to A1 we calculated, 3.125, parenthesis R, which is 4, and then n minus 1. Think about if you have any questions on the ones we've done so far for the 8.3 material. I can go back over any of them. And then we just have, what do we have, 2 more left? 1 more? Oh, my numbering's messed up on here. So number 19. Number 19 is if you had something like these first ones we did, here up here. Like if you had something like number 11 and they said, find the series. Series means you add up all those numbers going as far as they're asking you to add up. So instead of having to do things by hand, you have this formula, which is what we're going to use. And these ones are nice because it's easy to pick out the information. You don't have to do really calculations like you had to do when you find a arithmetic sum. And so the number up here, 9, that's your n. The 6 out in front, just like in the general formula, that's your A1. 3 in parentheses is R. And so what we'll do is we'll plug them into the formula, and then for the most part, you can do it on your calculator. So you write down that we're finding the sum of the first 9 terms equals A1, which is a 6, parenthesis, 1 minus R, which is 3, to the power of n, and this problem is a 9, over 1 minus R, which is 3. So you really should try to plug it into your calculator, kind of like what I'm about to describe, because if you do too much, usually we want you to show every step, but if you do too much rounding, your answer will change a lot by the time you write down your final answer. Like there was a question on the quiz that if you rounded the R value to 0.6, your answer was around a 4. If you rounded it to 0.66, it was around an 8 point something. If you kept it in a calculator, it ended up giving you an answer of 9, so it makes a huge difference. So what I would do is I calculate this part first. 1 minus 3 would be a negative 2, and I write it down. So then when I put this into my calculator, it's usually either a really big number or a kind of crazy decimal. You can leave it in your calculator and you don't have to write it down. So you should grab your calculator now and try it so you know that you would be doing these right when you eventually get to the test. Plug it in just as you see it. 1 minus, parenthesis, 3, and the parenthesis, to the 9th power. Hit enter. And this number is not too big, but it's negative 19,682. Don't clear your calculator. Right away, divide by negative 2. Hit enter. You're now at 9,841. Leave that in your calculator, and next step and final step, multiply by 6 to get your final answer of 59,046.